In this session, we will discuss about problems on nyquist plot, and you should know the procedure to plot the nyquist plot for doing the problems. Also, you are in need of a graph sheet, ordinary graph sheet to draw the nyquist plot. Actually, in the nyquist plot, it is very difficult to plot the exact curve. Mm, you can draw merely a same curve for the nyquist plot. There is no need of the exact plot. Okay. First of all, first question is draw the nyquist plot for the system whose open loop transfer function is g of s into h of s is equal to k divided by s into s plus 2 into s plus 10. Determine the range of k for which closed loop system is stable. So this question is asked for the KTU examination, that is in the supplementary examination September 2020. And here you are asked for the range of k. K is the gain value for which the closed loop system is stable. So you need to find the value of k. Before that, you have to plot the nyquist plot. So let us start with taking g of s into h of s. Here g of s into h of s is this one, and for the nyquist plot analysis you need to write this equation in the form of 1 plus st1, 1 plus st2, etc. Here it is s plus 2. There is no term for 1 plus st1. So you have to take this 2 outside in this bracket. Also from here, in order to make it 1 plus st form, you have to take 10 outside, so that you will get k divided by s into 2 into s by 2 plus 1 into 10 into s by 10 plus 1. This is, we are doing this in order to make this in the form of 1 plus st1 or 1 plus st2, like that. That is a standard form for plotting the nyquist plot. So this will give the value 0.05k divided by s into 1 plus 0.5s and 1 plus 0.1s. Now it becomes in the form of 1 plus st1, 1 plus st2, where t1 is 0.5, t2 is 0.1. So this is the standard form for drawing nyquist plot. So here you can see what all informations are obtained from this equation. First one, you can see that here the power of s is, that is the power of s is 1. That means the number of poles. Here in the denominator polynomial we will get the number of poles. Here there are 3 poles. What are the poles? S is equal to minus 2, s is equal to minus 10, s is equal to 0. So there are one number of pole which is situating at the origin, right? S, here there is a term s only, and that indicates that there is only one number of pole which is situating at the origin, and the other 2 poles are situating at the left half of S plane, right? So since there is only one number of poles situating at the origin, the type number of the system is 1. What is the order of the system? Order is 3, because here the total power of S is 3, right? S multiplied by S, and again it is multiplied by S gives S cube. So the order of the system is, this is a third order system, third order equation. So order of the system is 3 and type is 1. That you remember, that will be useful for plotting. So first of all we have to take when we are plotting this in the S plane, first we have to take a nyquist contour corresponding to this equation. See here, usually the nyquist plot we have discussed in the previous video, that nyquist plot is in the form of a semicircle. So we can take a semicircle which is enclosing all the right half of poles and origin of the closed loop transfer function. Actually this represents the open loop transfer function, and closed loop transfer function is g of s divided by 1 plus g of s into h of s. So here g of s into h of s is open loop transfer function or loop gain, and that have poles locating at the left half of the S plane. But when we are considering the right half of S plane, there may be poles or zeros. So we will take the nyquist contour which is enclosing all the right half of S plane poles and zeros. So we will take a semicircle like this. But you should remember one thing, that in this equation you can see It is a type 1 system, that means there is a pole at the origin, so we have to avoid that pole in that contour, nyquist contour. So here that pole is locating at the origin, that is marked by the cross mark. So we have to eliminate, or we have to avoid this, there is no need to take that point inside this nyquist contour. So we are selecting the contour, nyquist contour, in this form like this. That means this part is avoided. So this nyquist contour has three parts, different parts, and we can mark it as starting from this point. C1 is one section, C2 is another section, C3 is another section, C4 is another section. You should mark the arrow mark like this, such that it forms a closed contour. So this is the nyquist contour, and you can see here there are different parts, and suppose this is a semicircle which is having of 0 radius. We are assuming that it is having a 0 radius. Let this point be 0 plus, this axis is omega axis and this is real axis, and this point is 0. Then in the case of C1, omega varies from 0 to infinity. In the case of C2, this is a circular portion, and that we are assuming that its radius is infinite radius, that means r will be infinity, and its argument or phase varies from plus pi by 2. This axis represents plus pi by 2 to minus pi by 2. Next we will take the section C3, and in the case of C3 its omega varies from minus infinity to 0 minus, and similarly in the case of C4 it is a semicircle, its radius is 0, and here we can assume that its phase is varying from, here it goes from here to here, so phase varying from minus pi by 2 to plus pi by 2. These all informations are obtained from this nyquist contour in the S plane. Next what we want to do is, we have to transform each of the part of this nyquist contour in the G of S into H of S plane. So first of all we have to map C1 in the H of S plane. You can draw it in the graph sheet. Actually G of S into H of S plane means that it has also got a real axis and imaginary axis. So first of all, when we are taking C1, that is mapping of section C1, and you will get the information that in the case of C1 it is locating in the imaginary axis, and here omega varies from 0 plus to plus infinity, right? Therefore that means first of all we have to map this section, so that for that we are taking this equation G of S into H of S, and we will replace this S by j omega, so that we will get G of j omega into H of j omega. And in the case of G of j omega and H of j omega, omega varies from 0 to plus infinity. So we should draw the G of j omega and H of j omega curve. For that we can either substitute different values of omega to G of j omega and H of j omega. So what will happen when we are substituting j omega for S? So G of S and H of S will become 0.05k divided by, instead of S we are substituting j omega, here also we are substituting j omega, here also we are substituting j omega, so that we will get an equation like this. We can multiply the terms, so that we will get 0.05k divided by j omega into this term. This bracket is multiplied with this, so we will get this term, and the j omega can be multiplied inside, so that we will get 0.05k divided by minus 0.56 omega square plus j omega into this term. See, here we are actually, what we are doing is that we are making this rectangular form in the form of a plus ib form or a plus jb form, such that this minus 0.6 omega square forms the real part, and omega into 1 minus 0.05 omega square forms the imaginary part. So this is the equation that when we substitute for S is equal to j omega, and next we want to plot this curve, that is G of j omega and H of j omega in G of S, H of S plane, which is our ordinary graph sheet. So what will happen to this quantity when omega varies from 0 to infinity? That is our next consideration. Before that, if we are drawing a curve, or if we are drawing G of S, H of S curve in the G of S, H of S plane, we should mark the crossing point of the curve in the real axis. Suppose here suppose we have a graph sheet. Suppose that if the nyquist plot in the g of s and h of s plane cross the real axis, means that its imaginary part value will be equal to 0, right? When we are having a rectangular axis and we are having a rectangular form, when a curve crosses the real axis, that means that its point, that point represents the real part only. There is no imaginary term in this point, right? When it crossing the real axis, the imaginary part will be equal to 0. So in this equation we can substitute that imaginary part is equal to 0 when the nyquist plot crosses the real axis. When the nyquist plot crosses the real axis, then the imaginary term will be equal to 0, right? Because when it is that point, when it crosses real axis, means the nyquist plot point will be at the real axis. That means at the real axis, imaginary value will be 0. That means we will substitute that quantity. That is omega into 1 minus 0.05 omega will be equal to 0. But there is another point that when the nyquist plot crosses the real axis, that means the imaginary term will be 0, and when it crosses real axis, that represents the phase crossover frequency. So that phase crossover frequency we can represent it as omega pc. That means when omega equal to omega pc, that is at a phase crossover frequency, nyquist plot crosses the real axis such that the imaginary term will be equal to 0. So we can substitute omega pc into 1 minus 0.05 omega pc square equal to 0. So we will get omega pc equal to 4.472 radian per second. So this is the frequency corresponding to the real axis crossing point for the nyquist plot. Okay. When we are substituting this 4.472 in this g of s and h of s, we will get g of j omega and h of j omega equal to 0.05k divided by minus 0.6. Instead of omega square, we are substituting 4.472. So at omega equal to omega pc, we will get g of j omega and h of j omega equal to 0.05k divided by minus 0.6 omega square. Instead of omega, we will substitute 4.472. So we will get minus 0.00417k. That is the value of g of j omega and h of j omega. So we have to plot this point in the g of s and h of s plane. So we can mark this point at the real axis, right? Since it is a negative term, we can mark it in the negative real axis. So first of all, we will mark that point. This is a g of s and h of s plane. That is ordinary graph sheet. And in the ordinary graph sheet, you can draw this x and y axis. X axis corresponding to real part, which is u, and y axis corresponding to imaginary axis, that is jv axis. So first of all, we will mark this point as minus. See, you can see here that this point locating at the negative axis, negative real axis. So we will substitute that point, that is minus 0.00417k. That is this point. That means this point will locate at the negative real axis in the g of s and h of s plane. Now we got this point only. Next we have to draw the nyquist plot corresponding to g of s. Nyquist plot in the g of s and h of plane corresponding to the c1. See, c1 is this one. C1 is this one. In this omega equal to 0 plus to omega equal to plus infinity. When omega varies from 0 to plus infinity, what will be the curve of nyquist plot in the g of s and h of s plane? That is our consideration. So we have the equation for g of j omega into h of j omega. See, this is the equation. And we have omega varies from 0 to plus infinity. We can substitute different values of omega in this equation. That is g of j omega and h of j omega equation. And we will get the corresponding values of g of j omega and h of j omega. And from that values, we will get different points. And from the knowledge of that points, we can draw the nyquist contour in the g of s and h of s plane like this. So it is very difficult to see. It is very difficult to plot the nyquist plot by taking different points in the different omega points, and it is a lengthy procedure. So you should remember in such a way that in the case of an open loop system, which is a type 1 and a third order system, and in that case g of j omega and h of j omega will look like this. See, when omega varies from 0 to infinity, the curve will look like this. See, this is important point, that it crosses the point at minus 0.00417 k, and this curve is obtained by substituting different values of omega in g of j omega and h of j omega equation. So when we are substituting different values for omega in the g of j omega and h of j omega equation, that will take a lot of time. So you should remember that a curve will look like this, and you can see omega equal to always, when omega, see, the curve will end at when omega equal to infinity, the curve will reach at the origin point. So also for omega equal to 0, the curve starts from infinity point. That is why we are taking like this, and since C1 is in this direction, C1 is in the upward direction in the positive axis, so we will mark this direction like this. See, this arrow mark will be looking like this. Arrow mark is also important in this case. So next section, next we want to plot the section C2. This is C2. So mapping of section C2. You know that in the case of C2, that is a circle of infinity radius. In the case of circle of infinity radius, we can make the substitution like S is equal to the circular portion. In the circular case, the portion is this S value will be limit r tends to infinity, r e raised to j theta, where r tending to infinity, because we are taking the entire right half S plane, so r will be tending to infinity. When we are making this substitution, you know that when r tends to infinity, that means s tends to, r tends to infinity means that s tends to infinity. When s tends to infinity, you can see that we have the equation for g of s and h of s are like this. When s tends to infinity means that 1 plus st form will approximately equal to st. So we can write it as a 0.05 k divided by s into 0.5 s into 0.1 s. We are writing this because when s tends to infinity, st tends to infinity. So 1 plus st tends to st. So that is given here. And also in this curve, you know that in the g of s, also the nyquist curve, see, this is a curve, this is the C2 curve, and in this case r tends to infinity, and here the argument varies from, or phase varies from, if here phase varies from plus pi by 2. Here this is the point of plus pi by 2, this is 90 degree angle, right, plus pi by 2, and here last point is minus pi by 2. So argument varies from plus pi by 2 to minus pi by 2. So we will get the g of s into h of s like k by s cube, and in that case we are substituting s is equal to limit r tends to infinity, r e raised to j theta. So we will get g of s into h of s equal to k by s cube, which will be equal to k by limit r tends to infinity. Instead of s, we are substituting limit r tends to infinity, r e raised to j theta, r e raised to j theta all cube. Here when r tends to infinity, that 1 by infinity will have the form 0, and argument form will be e raised to minus 3 j theta. So that means when we are plotting nyquist of semicircle nyquist plot in the g of s and h of s plane, we will get another semicircle or circle which is having of radius 0. See, here this is the equation. G of s and h of s will have the equation 0 into e raised to minus j3 theta. When here theta varies from plus pi by 2 minus pi by 2. So when theta is equal to plus pi by 2, what will happen to g of s and h of s? G of s and h of s will become 0 into e raised to minus 3j pi by 2. And when theta equal to minus pi by 2, g of s and h of s is equal to 0 into e raised to plus j 3 pi by 2. This is simple substitution. And from these two values, you can see that when theta equal to pi by 2, the radius of the circle or semicircle will be equal to 0. When theta equal to minus pi by 2, the radius of the circular or semicircle will be equal to 0. We don't know whether it is a semicircle or circle, but you can see that the argument varies from minus 3 pi by 2 plus 3 pi by 2. So this is our nyquist plot in the S-plane, right, which is having infinity radius. So when we are plotting this nyquist plot in the g of s into h of s plane, you know that first point is that we have to draw a circle of 0 radius. So that we have to draw a semicircular portion or circular portion in the g of s into h of s plane, and its radius will be 0. That means that much small circle will be in the g of s into h of s plane. See here, there is an information, the phase varying from minus 3 pi by 2 to plus 3 pi by 2. That means when theta equal to pi by 2, see this is pi by 2, the phase is minus 3 pi by 2. That means 1 pi by 2, 2 pi by 2, 3 pi by 2. Again, when theta equal to minus pi by 2, the phase is plus 3 pi by 2. Again, there is a pi by 2, that is pi by 2, pi by 2, pi by 2. That means from minus 3 pi by 2 plus 3 pi by 2, there is 6 pi by 2. So that means 1, 2, 3, 4, 5, 6. 6 pi by 2 will be there, and the starting point is from theta equal to pi by 2. So we can start from here. See, you can either go in this manner or in this manner, and see here this is in the clockwise direction. So when we are plotting g of s into h of s plane, we have to go in the clockwise anti-clockwise direction. See, this is in the clockwise direction, so we have to go it in the anti-clockwise direction. That is why it is drawn in this side. There is a confusion. Sometimes there may be a confusion that you may draw it in this side, but actually this is going in this clockwise direction, so this should go in the anti-clockwise direction. So, and how long we should go is determined by this phase, that is from minus 3 pi by 2 to plus 3 pi by 2 we have to go, and so total pi by 2 number will be 6 pi by 2s. So we will go 1, 2, 3, 4, 5, 6. So, and also the arrow mark is in the flowing direction. So this is the nyquist contour corresponding to this section, that corresponding to C2 section, and that nyquist contour we will draw in the g of s into h of s plane. And also remember that this is a circular portion and its radius will be 0. So this will be a small circle. Okay, that is why it is indicating that r tends to 0. So next section is, once we draw the C2 section, next section is, what is the next section? Next section is C3 section. This is C3. C3 is going from minus infinity to plus 0. That means this is a linear section. That is why we are also, it is locating in the imaginary axis. So we are taking omega equal to minus infinity to 0 minus. So next our consideration is section C3. In section C3, omega varies from minus infinity to 0. This is minus infinity, that is curve, minus infinity to 0 curve, and it is in the S plane, that is sigma j omega. We have to plot this C3 in the g of s and h of s plane, which is having real axis as u, imaginary axis jv, and it is in the ordinary graph sheet. So how can we draw this C3? See, you have previously you have drawn C4, right? So, sorry, C1, this is going upwards and its values omega varies from 0 to infinity. When we are drawing this, we will, at omega equal to infinity, it will be near to origin, and omega equal to 0, it will be near to infinity. And C3 is similar to C1. There is a difference, that C3 is this like this. That means C3 is the inverse polar plot of C1. So there is no need to go for lengthy procedure. We can directly draw C2 from the knowledge of this curve. So for C1, the curve is looking like this, right? For C2 is the mirror image of C1. So we can draw the mirror image of C1 will looking like this. See, this is the curve. That is omega equal to infinity. It will be locating at origin, and omega equal to 0, it will comes to infinity. That means C3 is a mirror image of C1. So we can draw the C3 curve like this. See, you can C1 is like this. C1 goes up, so the arrow mark will go from here to here. Similarly, C3 is upwards, so the arrow mark will go from up. So the inverse polar plot of the C1 will give the corresponding nyquist plot of C3. So these two curves are mirror images. That means the inverse polar plot is given by the mirror image of the polar plot with respect to the real axis. The section C3 in S plane and corresponding contour in G of S and H of S plane will be the mirror image of C1. Okay. Next one we have to plot is C4. Next section is C. This is the question. We have plotted C1, C2, C3, and next we have to plot C4 section. In the case of C4, we know that C4 is a small circle with radius r tends to 0. So in that case, the argument varies from what is the direction of flowing of nyquist contour, that is from lower part to upper part, that is from minus pi by 2 to plus pi by 2 is the argument, and radius is equal to 0. In that case, we are making substitution. S is equal to limit r tends to 0 r e raised to j theta. So S is equal to limit r tends to 0 r e raised to j theta. We have to substitute in the G of S and H of S, and the argument varying from minus pi by 2 to plus pi by 2. See here, when r tends to 0, then S will be tending to 0, right? So we can write G of S and H of S will be equal to 0.05k divided by, instead of 0.5 S, you know that when r tends to 0, S tends to 0. So this term will be 1, and also when r tends to 0, this term will be equal to 0. So 1 plus st will be 1. So we will get G of S and H of S as 0.05k divided by S. So we can substitute the value of S is equal to limit r tends to 0 r e raised to j theta in this equation. So we will get G of S and H of S equal to 0.05k divided by limit r tends to 0 r e raised to j theta. So when r tending to 0, it will be of the form 1 by 0. 1 by 0 will be equal to infinity. So we can write infinity into argument term is e raised to minus j theta. Since it comes in the denominator side, when we are writing in the numerator side, it will be e raised to minus j theta. Infinity into e raised to minus j theta. So this is the equation, and next we have to plot this in the G of S and H of S plane. And here one thing is remembering that theta varies from minus pi by 2 to plus pi by 2. See, when theta is equal to minus pi by 2, G of S and H of S is equal to alpha into e raised to plus j pi by 2. Similarly, when theta equal to plus pi by 2, G of S and H of S is equal to infinity into e raised to minus j pi by 2. See here, we have to draw this in the G of S and H of S plane, which is having real axis and imaginary axis. You should remember that it will be either a semicircle or a circle, right? But it will have the infinite radius. So when we have this curve in the S plane, which is an nyquist contour, it goes from minus pi by 2 to plus pi by 2. So the arrow mark will be looking like this. So we should remember that when we are drawing the corresponding nyquist plot in the G of S and H of S plane, the nyquist plot will go in the clockwise direction. We don't know whether it is a full circle or a semicircle, and that will be determined from this argument term. Here when theta equal to minus pi by 2, so theta is minus pi by 2, the value will be is equal to plus pi by 2. When theta equal to plus pi by 2, value will be equal to minus pi by 2. When we are taking the phases, you can see that here there are 2 pi by 2. That means total phase is equal to plus pi by 2 to minus pi by 2. That means pi by 2 plus pi by 2. That means 2 pi by, the 180 degree will be there. So we have to take 2 pi by 2s. That is 2 pi by 2s will be, see this goes in this right portion. So we can draw this similar nyquist contour in the G of S H of S plane in the right side. But you should remember that it is a semicircle because there is only 2 pi by 2s. So 1 pi by 2 is here, other pi by 2 is here. Also the arrow mark will be in the opposite direction. Since it goes in the anti-clockwise direction C4, this curve will goes in the clockwise direction. And also we should remember that the radius will be infinity. So this is the point. In the previous case, you can compare the previous cases. See here, C2 goes in the clockwise direction. So the corresponding nyquist contour goes in the negative direction. Also here there will be 6 pi by 2s. Here we are starting from plus pi by 2. Here we are starting from plus pi by 2. 6 pi by 2s are 1, 2, 3, 4, 5, 6. And here arrow mark, here this arrow mark is clockwise. So this arrow mark will be anti-clockwise. Sometimes it may go in this direction also. But you should remember that for pi by 2, first you have to achieve minus j3 pi by 2. So that is why it is going in this direction. So next we can plot. Next we can see we have got the nyquist plot for all the 4 contours, nyquist contours in the S-plane. Next we have to combine all these contours. So the combined contour will be like looking like this. We have a section corresponding to C1 like this, and also we have a section corresponding to C2 like this, and we have a section corresponding to C3 like this, and also we have a section corresponding to C4 like this. But there is no connection when we are drawing in the graph sheet, but we have to connect each of the point based on the arrow mark. So you know that it goes in the central circle goes in the anti-clockwise direction. So this goes in the anti-clockwise direction, then it touches the curve which is in the third quadrant, so that it will go look like this, and this curve will touches the other curve like this. And next also we have a section here, so a continuous flow will be there. That is this is the way we are connecting all the curves based on the arrow mark. So arrow mark is an important quantity. So this is a complete nyquist plot. You should remember this. See, this is obtained by combining all the curves for C1, C2, C3 and C4. So you may draw an ordinary. There is no need to draw the exact curve, but it should look like this. Next we can analyze the stability. When see, we have got a point in the real axis that which is, see, this we have got a point that this curve touches the real axis at minus 0.00417 k. So that is an important point, that is when minus 0.00417 k equal to minus 1. See, we have gone through the nyquist stability criteria. In the nyquist stability criteria, its stability is predicted based on the point minus 1 plus 0j. So we have to take that minus 1 plus 0j point. So we are substituting the real axis point, real axis crossing point as minus 0.00417 k equal to minus 1. That means the contour passes through the minus 1 plus 0j point, and when it passes through the minus 1 plus 0j point, the corresponding k value will be equal to 1 divided by 0.00417. That means equal to 240. That means this is the limiting value of k for which this system is stable. That means when the contour passes through the minus 1 plus 0j, the k value will be equal to 240. Next we will consider the different values of k. That means we are analyzing it with two cases, that is when k will be less than 240, when k will be greater than 240. What will happen when k will be less than 240? When k less than 240 means that this term will be a negative term, but it will come closer to the origin 0 and minus 1 plus 0j. So when k is less than 240, the contour crosses the real axis at a point between 0 and minus 1 plus 0j. See, if this is the curve, when k equal to 240, this curve will, this is the point, this point will be minus 1 plus 0j. When k is less than 240 means that the curve will come to nearer to the origin. This curve will be shifted to nearer to origin. the complete curve is shifted to this origin. That means this point will be between 0 and minus 1 plus 0j. That means minus 1 plus 0j will be outside this nyquist curve. Similarly, in that case, we can see that when we are going through the nyquist plot along the indicated direction, we can see that minus 1 plus 0j is not encircled. So there is no encirclement of minus 1 plus 0j, and then we can say that the open loop system, also we know that open loop system has no poles on the right half of the S-plane. So this is the nyquist stability criteria we have discussed in the first case. In that case, the system will be stable. That means no encirclement of minus 1 plus 0j point, and also there are no poles on the right half of the S-plane. Then the system will be stable. That is the nyquist stability criteria, first nyquist stability criteria. So this happens when k is less than 240. When k less than 240 means that this quantity, right? This quantity, when k less than 240 means that this quantity will be shifted closer to origin. That means the curve will be, that means k less than 240, the contour crosses the real axis at a point between 0 and minus 1 plus 0j. So that there is no encirclement of this point by this curve, and also there are no poles at the right half of the S-plane. So we can say that the system will be stable. Then what happens when k is greater than 240? When k is greater than 240, that means the contour crosses the real axis at a point between minus 1 plus 0j and minus infinity. See, when k is greater than 240 means that k greater than 240 is, this will become more negative. That means more negative means it will move away from the origin, in the negative direction. So the contour will be going away from the origin, so that minus 1 that contour will encloses the or encircles the minus 1 point, minus 1 plus 0j point. So, see, you can see here that when k is greater than 240 means that this curve will moves away from this origin. That means this will go shifted to another point. That means minus 1 plus 0j point is here, that will be encircled by this curve, and we have to check how many times this encirclement takes place. See, if this is the minus 1 plus 0j point and k is greater than 240 curve is here. So if you are starting from here, you can see it will go in the arrow mark direction like this. So first encirclement in the clockwise direction. Next also there is second encirclement in the clockwise direction. See how many times it encircles this point? 2 times. See, once more this goes when we are starting from this point, that is the limiting point, in this form, going like this. See, up to this point there is a one clockwise direction encirclement, right? It will not stop here, it will again continue in this direction. There is one more chance of encircling the point, so that if the point is here, this point will be encircled by this nyquist curve 2 times in the clockwise direction. So we have to go for the nyquist stability criteria. In the case of clockwise encirclement, you know that the system will be unstable. That means when k is greater than 240, the contour crosses the real axis at a point between minus 1 plus 0j and minus infinity. And on traveling through the nyquist plot along the indicated direction, it is found that the point is encircled in the clockwise direction 2 times. Since there are 2 clockwise encirclements and no right half open loop poles and closed loop systems has no 2 poles and right half S-planes on the right half S-plane, therefore the system will be unstable. So when there is a clockwise encirclement and there are no poles on the right half of the S-plane, there are no point or poles of the closed loop system and on the right half of the S-plane, then the system will be unstable. So the system will be stable between the points 0 and 240. So this is all about nyquist plot. Thank you.